So yeah, welcome everyone to the September meetup of data science on AWS. If you're new to this meetup, we're running this every month. Chris Fregly and me are hosting this. Both of us are working at AWS. I'm a developer advocate for AI/ML. Chris is working as a specialist solutions architect for AI/ML. And we've been running this community and those meetups for a long time. And I do have the pleasure to host today's session. So if you're interested in checking out our meetups, I'll post the links here, and I posted it already in the chat as well. We also co-authored a book together, Data Science on AWS, available at O'Reilly. And I do have some exciting news. So if any one of you is Polish speaking, we just published our book translation in Polish. So in case that's your favorite language, I'll post the link here in the chat. Or if you have friends speaking Polish, I'm super excited to have yet another translation available for this book. So really happy. And yeah, thanks to everyone who worked on this translation. All right, coming back to the meetup. Again, we're hosting this every month, so feel free to check it out. We do also have published already some of the talks for the upcoming sessions. So if you want to poke around there and see what we have lined up for October and November, feel free to do so. And today, I'm super excited to welcome two speakers to the meetup. First will be, I'll zoom in here a little bit, Mark McQuade. He's working at Roboflow, Field Engineering and Customer Success and Partnerships. And he will give us an insight in how to use Roboflow to build computer vision applications, and obviously show us a little bit what's behind Roboflow. We'll see a demo as well, so super excited for that. And then our second speaker today is Zhang. He's a product manager here at AWS. And he will give you a quick intro if you haven't seen it yet or you're not familiar with it into Amazon SageMaker JumpStart. It's an easy way to get started with machine learning on AWS. And he will talk a little bit what it is. And also, for those of you who might have heard already about it, what's new with SageMaker JumpStart. So super excited for our two speakers today. And without further ado, I'll hand it over to you, Mark. Let me stop my share here. Here we go.
Perfect.
Take it away. And for everyone, if you have questions, put them in the chat window. Thanks.
Everyone can see my screen?
We can, yes, perfect.
Perfect. So thank you very much for the setting the stage there. I'll go through a few slides. I'm not going to go crazy in the slides, but just to kind of give an overview explanation of Roboflow. And then I'll get into a demo, which is always much more exciting. Perfect. So what is Roboflow? So Roboflow is an end-to-end, we call it image to inference computer vision platform. So, we accelerate development of computer vision, right? So we want to put computer vision into the hands of every developer and every application, right? And we think that is the way of the world and what is to come for computer vision. So, we're a partner to global businesses. We have over 60 of the Fortune 100 companies using Roboflow today, which is fantastic. And we're Series A. We've raised $22 million in funding, and we have some top investors in the VC side. So lots of momentum. We're doing great, and as you can see, some of our big logos there. USG, Rivian, Walmart, Cardinal Health. So really great time to be at Roboflow. So over 140,000 developers use Roboflow. And as you can see, I'm not going to go through this, but you can see some of the use cases, right? Computer vision really covers every domain. People often ask me, what's the biggest domain for computer vision? And I don't really have an answer for that because it covers everything. Anything you want to automate the sense of sight, you can use computer vision, right? So, and the 140,000 developers, that's talking about the core SaaS app, right? So Roboflow has two kind of entities, right? So we have Roboflow platform, which is our core app. And then we have a second entity, which is an open source, open community entity called Roboflow Universe. So what is Roboflow Universe, right? So it's the largest resource of computer vision models, projects, data sets out there today. So we have over 80 million images in Roboflow Universe, 115,000 plus data sets, and over 11,000 pre-trained models, right? So this is just an open community where people go in and they share their project, they share their data set, and other people can then use it, and they can fine tune it further if they want for their use case, or they can use it as is. And add it into their application. So as I said, kind of two entities, the core app and then the Roboflow Universe piece. We're really kind of helping democratize computer vision across the board. So why Roboflow? I guess that's a great question, often get asked, right? So it's the robustness of the process, right? End to end, as I'm saying. We kind of wrap in 5, 6 other services that you can think of into one platform. So rapid prototyping as well is a big one, right? So you can literally take a model to production in a week using Roboflow as opposed to traditionally weeks or months, right? Best in class labeling. So labeling is what we originally started at. We were founded in 2019 and we were a kind of main focus on the labeling platform. So that's kind of our most mature piece from the Roboflow platform. And I'll showcase that in a bit. And specifically label assist, which is, AI backed labeling. And scalability, of course, right? So over 100,000 developers, over half the Fortune 100 using Roboflow today. So we're fully scalable, ready to go for any workload. This is kind of what it looks like, an end-to-end workflow for Roboflow, right? So you have the ability to collect images, you then organize those images, right? And you get to collaborate with teams, then you label and annotate those images accordingly. And you process those images, right? So you add processing to them, you do augmentations, you train a model, one-click train, deploy a model, one-click deploy, and then you display the results, wherever that may be. So very quick overview, but as I said, complete end-to-end. And this is the last piece that I like to highlight is the active learning pipeline. Many people probably know what active learning is, but it's the ability to automatically improve your model over time. So this is something we really lean into at Roboflow, right? It's the ability to, you're capturing images as you can see, right? And you're inferring them, right? And you're saying, okay, if this image is good, maybe you set a threshold of 50% confidence, right? So if it's over 50% confidence, it's a pass. And then you do some kind of post-processing, some application logic with it. If it fails, right? So if it's a 37% confidence, as you can see here, you pump it back into your Roboflow project. You then re-annotate the image, you pump it back into your model, retrain a model, and your model is just constantly improving, getting smarter over time. So this is something we really like to push these days, is the full active learning pipeline. Okay, with that, I'll hop into the demo. If anyone has any questions, I know I went through that quick because I wanted to showcase the demo, but please don't hesitate to write in the chat.
Yeah,
sorry,
just quick, Mark. Yeah. One question here. If you could confirm the number, how many developers you have right now? It seems like an amazing number.
Yeah, so it's actually about 140,000 developers use the core app, okay? And we're going to hit 100,000 developers using Roboflow Universe shortly. And Roboflow Universe was just launched, really launched. We soft launched it last year, but it was really launched in January 2022. So, we're already going to hit 100,000 users of that platform. So, I mean, if you're crossing over both, we're hitting up to 250,000 users if you look at both platforms. So yes, great momentum, huge user base. And that's great for everybody, right? Because the more users, the more collaboration, the more people sharing projects and data sets and images. So fantastic. Okay, so I'm in Roboflow right now. Okay, so this is what it looks like when you log in, right? app.roboflow.com. And so we have the context of workspaces and projects. So this is my workspace, right? Mark McQuade is the workspace. And then you create projects from within, okay? So you have the ability to create a new project, you name it, and you select your project type, right? So this is what we support, right? Single label classification, multi-label, instance segmentation, semantic segmentation. Now, we don't support semantic segmentation end-to-end quite yet. So end-to-end, I mean training a model and deployment of a model. And key point detection is actually not supported quite yet. And this is something that's on our roadmap. So I already have a project created. So I can go in here. So this is a great project I like to showcase because it really highlights the power of Roboflow. Okay, so it's a box punch detector. So I'll give you some context. It's just literally detecting what type of punch is thrown in a boxing workout. And as you can see, this is actually me. Something I came up with this idea because I think it's extremely valuable to know what type of punch you're throwing when you're working out, if you're doing a boxing workout, because then you know which punches you need to throw more of or less of, right? It's all about the workout. So if you notice you're not throwing enough jabs or enough hooks or crosses, whatever that may be, you can then see how many you're throwing and then adjust your workout accordingly. Okay, so the power of this, I like to say, is the fact that I filmed this in my garage on an iPhone. And then I can take it all the way to a production level model, right? And very easily. So I'll show the full end-to-end ability of this here, right? So I'll kind of just step through the project. If anyone has any questions, just throw them out in the chat here. So this is just a README, right? In the overview, you just create a README for your project, right? Just so others can know, because if you make it public and you put it into Roboflow Universe, this allows for tagging and searchability from within the public space. Okay, so here's where you upload your images. So we'll do that right now. So let's just grab a video. So you can drop in videos too, and you cut them by frames per second. Okay, so I could set this in whatever way I want, right? 20 frames per second, go higher, whatever you want. So for this, I'll just keep it at 1 frame per second. I'll choose that frame rate and I'll drop it. Okay, so it's chopping up my video into images, into frame rates with one frame per second, and then it's throwing them into the project. So I won't, as you can see, it's gonna take a minute here, but nothing extravagant. So there they are, they're all there, they've cut up. So you just hit your finish upload, okay? So then it takes them all in to your project. Let's finish for a second. Perfect. So then you have the ability, this is when we get into that piece, what I told you, the collaborative annotations, right? So here you have the ability to assign the person to label them, right? Label your images, right? So you can imagine you're on a team that everyone's doing labeling. You can assign the images accordingly, so one person just doesn't get assigned them. So here we'll just assign myself all the images, okay? All right, so now we're in the annotate section, okay? So from within the annotate section, so click out here, you see you have this kind of board, right? So you have an unassigned board, an annotating board, and then a data set board. So what happens is when the images are assigned, they go into the annotating board. And again, when they're unassigned, you have to assign them, they move over accordingly, right? And once they're all done annotating, they move into this data set column here, okay? Now I'll show you what it looks like to annotate from within Roboflow. Sorry, I clicked on the wrong ones there because they're all annotated. Unannotated. So let's go in here. We'll just click. Okay, so now I'm in our annotate tool, our labeling tool, right? So as you can see, there's some shortcuts here, right? Where you have the ability to select what you want to do. See, you can do a polygon if you wanted to do a segmentation project, bounding box. You can mark the image as null, and you have the label assist, which I'll showcase in a minute. And there's some shortcuts here, which is much easier to use the shortcuts, mind you, but just to showcase those. So what you'll do, for my case, let's just say, I'm going to do this as a cross. Okay, that's it. Next. Okay, it's very simple, right? Very simple. Okay, and then next. Okay, there you go. So you're just doing bounding boxes, right? That's it. Very simple. Want to be the bag. There you go. Bag. Next. Okay. So from there, I do want to showcase the label assist feature. So what you do for label assist is you select a model that you've already trained, which allows you to already get a leg up on the annotation. So then as you select that, the annotation will start appearing automatically, and you could keep it or you can adjust it accordingly. So if I hit continue here, it just loads the model here. You can select the classes that you want to keep in. So let's just keep them all for this demo. Let's annotate. Okay. And then you have the ability to set the confidence threshold, right? So as you can see, this one came up as a jab. I will say up front, this model isn't great because there's not a ton of images. This is more just to showcase the ability of the platform and the end-to-end capabilities. But this is what it'll do, right? It'll go there. There you go. It's giving you, it's automatically seeing, a class from within. So you kind of saves you time on your whole labeling piece, right? And as I said, you can set the confidence threshold here higher or lower. Like if you set it to 10%, right, then it'll grab more, right? If it's grabbing something in the back there, obviously you would like to play with this depending on, what you're trying to do. Okay, so let me go out of here. I've already annotated some images, so we don't have to do anything. But what you'll do is you would then go in. They would go into this data set side, and then a button would up here, and you would go add to data set. You do that. So now we want to generate a new version, right? So within Roboflow, a version is kind of the final piece of the data set that is ready for your model. So I go to generate. As you can see, I already have a bunch of models generated here. Okay, and let's look at one. So if you look at what you're getting once you have a model trained, so you have some results, right? So you get the map score, the precision, the recall of the model. You have the ability to drop an image right in from here, which you're allowed to test it. You could then click on here like code samples, which will show you, it'll take you in to show you how to deploy it via our API, right? Our hosted API. There. And then it also shows you, like, obviously a big use case in computer vision is deploying to an edge device, right? So this shows you how you can deploy it to an NVIDIA Jetson or a Luxonis Oak camera. And then you can see how, some information, how I split the images, right? All these things, some augmentations that I added, which I'll go into right now. Okay. So what you'll do when you generate a new version is you have the ability to perform these, as you can see. So here's my train test split, which you can also modify if you need to. You can rebalance it. Let's just continue here. But then I mentioned a couple of times these pre-processing, these augmentation steps, right? So you have the ability to do things to your image, right? To allow your model to be smarter, to get better, right? So certain things are like you can isolate objects, you can do static crop, right? You can do grayscale, right? And we give you little tips on why to do it, right? Rule of thumb, when speed matters, color isn't a valuable signal, right? So you're kind of just improving the data for your model to allow you to train a better model, right? You have the ability to resize as well. And sorry, go back there. You could also do tiling, which is important for like aerial imagery, really small objects. You can do tiling and it'll break the image into multiple images based on what you set your tiling to. And you could filter all the null images, right? So let's apply that. Cool. We want to not include any null images in the training, what you're saying. Okay. So that's the processing piece. Then we get to augmentations, right? So augmentations is, essentially creating, generated versions of your data, right? Think of like synthetic images. So, when you do this, if you do this, right? If I add in a flip, right? So I'm flipping an image vertical and I'm flipping it horizontal, okay? And that's going to create a synthetic image of that image in a horizontal manner or a vertical manner, okay? Same with crop, you can crop it. And there's a bunch of augmentations that we use that are just, it's really dependent on use case, where, what you want to do. And it's really kind of like an art, right? You can play with the augmentations and the processing until you get to a point where your model is giving you the results you need. And as you can see, right, like I've trained a bunch of models here. It's very easy to do, right? It's not, labor cumbersome. It's not time, cumbersome. It is very easy to do. And as I said, lots of augmentations we offer. So you could add saturation, hue, right? Some brightness, right? So let's say I wanted to add brightness up like this, right? Really just toggle it. And it's all really depending on what you want to get out of your data set. You could add noise and blur to try and confuse your model a bit to make it smarter as it trains. You could do mosaic as an example, which combines multiple photos from the training set into a collage, right? So lots of opportunities to do augmentation, okay? So then once you do that, you then have the ability to, how many images do you want to generate? Okay, so, you can generate 1, 2, 3, 5, 7, all the way up 10x or even higher if you're in the higher level tier. But you have the ability to, create these synthetic images. So your model has more training images, right? Always a problem within, machine learning, especially computer vision, is having enough images. So this is the way that your model can create those images without actually having to go source them directly. And then you just click generate, okay? So what that's doing here is zipping up the images. There you go. And then it's essentially saying, okay, you've got everything here. You can take a look at how you created that version, and then you could train a model. So let's train a model. Now for training, you have two pieces. You can do a fast model or an accurate model. Obviously, a fast model is a smaller model under the hood, and an accurate model is a bigger model. It's going to be more accurate, right? Slower to train and infer, but more accurate, or quicker to train, less accurate. So we'll just kick off an accurate train here. And as you can see, you could train from a checkpoint, right? So you don't have to always train from scratch. So you have the ability to grab one of your previous versions as a starting point, right? That's the kind of key model behind transfer learning, and then train from there. So you have a great starting point. Or you could just train from scratch. Let's just train from scratch for this. So what you can see it's doing, it's zipping up the files, and then it'll kick off a train job. Okay, so training in progress. As you can see, it could take up to 24 hours, right? Or it could be 10 minutes, right? It depends on the size of the data set and the augmentations and processing that you used, okay? So yeah, I mean, I have all these already. As you can see, when I go in, you can see that, the scores, you just, different augmentations and processing that you put into play, improves your scores, right? So it's all about trial and error and getting to a point where you're prototyping to a point where you're going to be successful with your model. Okay, so from there, we have this deploy tab, right? So this is something that's actually fairly new. It's actually really cool. So I have the ability to drop a video or an image in here. So let's drop a video in, and you'll see here, right? So you can actually change the confidence threshold here, the overlap threshold, and as you can see on here, here's the predictions all coming in, right? How accurate the predictions are. Well, we'll just say that, I probably should be training this model a little better with more data, but as you can see, you get the point, right? So it's capturing, each one, each punch thrown. It's capturing bag all the time. So I added a bag class here and tried to capture the bag in every image. So as you can see, really cool stuff. You're getting your class here, your confidence, and the coordinates of your bounding box. Perfect. Yeah, so as I said, really cool, really powerful in my opinion, because this is me in my garage filming myself all the way to a production ready model. If I improved it, of course, production ready. I've got an API endpoint now with my version. I could pop it into any application that I want. And yeah, I mean, so let me just show one more thing here, and this is the health check. So this is something that just allows you to get a little bit more granular with your data, what your model's doing. So it just shows the images, the annotations, shows your class balance, which is something that's very important, right? From within when you're training a computer vision model, right? You don't want to have too much underrepresented classes, too much overrepresented classes. As you can see, I have a lot of underrepresentation here, probably why my model isn't performing fantastic, but this would allow you to then gauge, okay, how do I fix my model? And then we provide some other things like these dimension insights, this heat map, right, which shows how many types of punches are in your or how many types of classes are in your data set. In my case, punches, and then a histogram of object by count by object. And so what this is doing here, as you can see, is showing like, okay, my counts are, and that's the goal of this model. That's why I built this model, right? Was to do counting. Okay. So I'll quickly show, I'll be real quick here. So obviously I wanted to mention as well, under the hood, why I'm on a data science for AWS course, we use AWS under the hood for all our model training and deployment. Okay. But I also wanted to showcase another last piece here is what you can do with your predictions, right? And this is something that's a common trend out there now, like predictions now what? Right? Like, what do you do? So maybe your preds are controlling a robot or something like that, but what else do you want to do with it? Right. And in the typical data world, you'd want to do more with your predictions than just, kind of control an application. Right. So I put together this very easy script here where it just, I'm installing Roboflow via our pip package and Boto 3. Right. And then, this is how you bring in your Roboflow project into your code here. So you just, through the Roboflow pip package, you put in your Roboflow API key, which I've blocked out for this, but and then this is how you bring in your workspace dot project. Okay. And then you have the ability to download that model version. And I should probably showcase that real quick. When you go to your version, you have the ability to export. So this is all the versions, all the formats that you can export your data to, right? So Coco JSON, CreateML, Pascal Voc, CSV, right? So once you pull them here and you export them, they're in a format that's ready for you. So we're also helping people train models on their own as well. We're not saying you have to train from within Roboflow. A lot of people take their data sets that they've prepared and prepare them off site. Okay. So back to this quickly. So what I do is I pull in pull down my data set and my project and my model into my collab notebook. And then I just run inference on the images, right, that I have in here, right? So I've already done this, but here I'm just installing the AWS CLI. So as you can see, okay, so I just run a quick script here to run preds on my model, feed data into my model, take the preds and then throw them up to S3. Okay, so why is that important? I think it's important to then do more with your predictions, right? So here's my predictions in S3. Here we go. Here is my predictions, right? And they're all in JSON format. So what I did here for this use case is I won't get in, I know I'm running out of time, but I won't get too crazy here. So I used a glue crawler and crawled my data, my JSON data, and I created a database and a table from within that, right? Called Preds version 5 CSV. So what I'm trying to do is I'm converting the predictions to CSV. And then from there, once I do the crawl, I went into Glue Data Brew. Into my projects. And I literally just, ran a very simple recipe to convert the JSON in S3 to CSV. Okay. And why did I do that? Because obviously working in CSV is a lot easier for any BI or any analytics that you want to perform. And you're creating that one table as opposed to separate, JSON files that come in when you input the preds, they come in each individual JSON files. So, and I won't even get into this because this is loading, but I did it, I swear. So I converted it to S3 or to SCSV. And then from there, now you have the ability to query it, right? So now I can query as I want, right? So as you can see, I'm running a query here, just a SQL query saying, how many hooks did I throw? And I'm getting the number 8, right? Or, I can see all classes here, right? So this is just a preview of the entire table, right? And it's showing, the class, the confidence in it, the height, and where the path is to the image. And here's another one, counting the jabs, right? So I threw 3 jabs in the images that I loaded in, right? And then from here, the sky's the limit, really, right? I mean, you can upload this data, into a Redshift data warehouse for further analysis. You could, build dashboards out of it using QuickSight. You can go back into Glue Data Brew and do much more with it if you'd like. But this just showcases the ability to kind of get to that end state that my goal from the beginning was to count how many different punches were thrown. Very easily to do in this point, because now I can just run SQL queries to do anything I want on my prediction data. Yeah, and I think that's it for me. Hopefully I didn't take too much time.
No, that's perfect, Mark. Thanks so much. Really exciting to see Roboflow in action here. People really enjoyed the practical demo. We do have a bunch of questions here in the chat. So let me just scroll up here and make sure we're touching on those. So the first question that came in earlier was to share a little bit more about the platform and how scalable it is. So I think we saw the platform in action, really cool. Is there anything you want to add in terms of maybe the scalability of the platform?
No, we're essentially infinite scalability because AWS is infinitely scalable. So, I mean, we're not going to have any scalability issues running on the platform because we are fully backed by AWS. So, yeah, the great thing about AWS, right? Infinite scalability. We'll call it infinite.
All right, I'll leave that there. Next question. Isn't the confidence of 50% like a coin toss, like saying the model has no idea? I think that was in the early demo you did there.
Yeah. Yeah, great question. Great point. Great catch. The reason I kept the confidence at 50% mainly was just because I wanted to showcase the preds coming in a visual form because the model is not great. I only started with, I think, 200 images. So no, typically you would go with 80%. Our inference API confidence threshold is 80% by default. And you can adjust that accordingly. But it also does depend on, what your use case is, right? Sometimes confidence of 50% may be all you need for your business use case. It always isn't, 99.9% accuracy.
Right. Okay. Next question here. How did you define the original class? I think that was around when you uploaded the data set.
So I define when you draw the bounding boxes on it, then you define them from within, right? So literally from within the annotation tool, bounding box, and then you type it in that class, and then that class is now stuck, right? It's sticky class from within the annotation platform. And then if you want a new class, like say I did the bag for the first time, I just type in bag, that class is now stuck from within the platform. And then you have the ability, once you have all your classes set, you really have the ability to start using keyboard shortcuts and like left arrow, right arrow, like N for null, right? So you can really fly through once you have that set. So you literally define them from within the annotation tool when you're doing the labeling.
Perfect. And then we had a question, I think you touched on it in the last part here. How can I integrate Roboflow with our existing stack in AWS? So you showed a lot of tools right there at the end, right? Integrating with Glue for the data catalog side, running queries with Athena. Anything you want to add to that maybe?
Yeah, so actually, this is something we're actively working on. I'm glad someone brought that up because we're actively working on that. So first off, Roboflow is an end-to-end platform, but you have the ability to integrate Roboflow into pieces of it. We don't say you have to use it all, right? So let's just say that. Now we are in the process right now of extending our pip package, our API, to allow for programmatic access to things, right? So training a model programmatically is not an option right now from within Roboflow, right? So much is still required from within the UI, but we are extending our pip package and our API to allow these things programmatically, right? So once you get to that point and you could do programmatic, then you could integrate Roboflow into any step of your MLOps pipeline, right? You could use another annotation tool and then use Roboflow for training simply by making an API call. Same with deploy. You could use the Roboflow inference API. Just each kind of plug and play it into each piece of your stack as you go, which you can do today. It's just a little limited. But once we get fully stacked with our API extensions, specifically our pip package, then you'll be able to do everything. Plug it and play into Kubeflow, MLflow, SageMaker pipelines, whatever you like.
Yeah, and I just see here follow-up comment, a +1, that it would be great to have that programmatic access. Yeah, absolutely.
I'm pushing for it.
Yeah, keep the feedback coming, right? If you have another use case, you want to see another integration, let Mark know, let your contacts at AWS know, let us know here. Happy to hear from you what you're looking for, if we haven't mentioned it. If not Edge, then where are we deploying our models? Model deployment options.
Model deployment options. So you could deploy to an edge device, of course, as mentioned, or you can deploy to our inference API, right? So as cloud, you can integrate the API into your application. Or you have the ability to bring your data that you've prepared in Roboflow down, train your own model and deploy it anywhere and deploy it anywhere you want, right? So that's kind of the way we package it today, is deploy to edge device, because we have a Roboflow container. So let me be a little bit more specific on that. We have a Roboflow container that you deploy and pull down. Sorry, I see a question coming. I mean, are we deploying it on AWS? Sorry, I missed that one. I lost that question.
Yeah, follow-up question. I mean, are we deploying it on AWS or Triton? Like the model endpoints, yeah.
So we kind of mask that away, right? So we deploy it on AWS. So we don't actually you don't have to deploy it on AWS. Mind you, you can deploy it yourself on AWS by exporting the data, training a model in SageMaker, and then deploying it on SageMaker, Triton, or wherever you want. We're also, some things in the works right now where we're trying to extend it a little further and allow for a seamless deployment to SageMaker as well. So yeah, and kind of back to my original point, Roboflow container allows you to take it and deploy it to other devices. So edge device at Jetson and Nano, Jetson Nano, Luxonis Oak, any of those things, as well as our inference API. Hopefully that explained it.
All right. And I see there's a little more questions coming, so we probably have to cut at one point.
Sure.
Let's see what we can, what modeling methods are used in the backend. Let's say you want to publish a paper based on the work in the methods, you'd need to specify what ML modeling method used.
Yes, you probably would. So let me say, we don't typically we don't typically talk too much about what we're doing on the back end from a kind of a secret sauce perspective. So we don't typically release the architecture of what we're doing. I mean, if you wanted to write a paper on something, I'm sure we would help you out. You could be in touch. You can get in touch with me. We could work on something, but we just don't typically let everyone know what we're doing on the back end because it is a secret sauce that we built internally, and it's a special thing we do. So we kind of mask that away. I'll say that. And I apologize if I'm being cryptic.
Alrighty. It is what it is, right? All right. Let's do one more, and then maybe you can answer the rest in the chat window. I want to make sure we have time for our second speaker as well.
Sure.
But how easy is it to change some steps, parameters, models in the pipeline, and then compare the results from across runs, and maybe combine that with where you get the analytics of your training and test?
Yeah, so what you can do typically in the Roboflow world is you would keep training models, right? And then you would compare them based on their health score or their map score, precision recall from within, right? So and you would kind of track your pre-processing and augmentation that you would do for each version, right? Every version has a number and it's all aligned, right? It's time-stamped, you know which version you're doing. You don't today have the ability to go in and tweak any parameters or hyperparameters of the model, right? We really try to make it as simple as possible for developers to one-click train and one-click deploy, right? So that kind of, we take away that piece. So it's not like you can go in and change any of the hyperparameters, but you can go deep into each version that you train to see how it's performing and then adjust accordingly based on those metrics and train a new model, right? Rapid prototyping is essentially what it is.
Perfect. All right, we do have a couple more questions. So Mark, first of all, thank you very much for presenting today and showing us a great demo here. Really exciting to see where Roboflow is going. If you have a couple more minutes, maybe you can answer the other questions we didn't get to here in the chat directly. And yeah, thanks so much. And we'll transition over to our second speaker. Thanks, Mark.
Thanks, everyone.
All right, and next I welcome Zhang on stage. Lee is a product manager at AWS, and he will show us from one easy to use tool to another one, how to get started with ML on AWS using Amazon SageMaker JumpStart. And Lee, the stage is yours. Yeah, take it away.
Thank you for the introduction. I'm trying to share my screen. Can you let me know when you can see the screen?
Yeah, we can see your browser window with JumpStart. Perfect.
All right. Yeah, thank you very much for inviting me, giving me the opportunity to talk about my product. So I'm the principal product manager for SageMaker JumpStart and the SageMaker building algorithms and reinforcement learning. Today, I'm going to introduce you SageMaker JumpStart. I don't know if everybody is here familiar with what it is, so let me first, show you how to get to it. With the name SageMaker JumpStart, our intention is to make it easy for users to get started with using SageMaker quickly, to save your time and hand it to you many of the pre-prepared content such that you can get started using SageMaker really quickly. So SageMaker JumpStart lies inside of SageMaker Studio. So this is the SageMaker Studio landing page. When you first log in, you will see one big card on SageMaker JumpStart, one big card on Autopilot, and another on Data Wrangler. And below, you have all the other features from SageMaker Studio. So if you can either click the big card, or you look at on the left, the golden tripod. And that's what SageMaker JumpStart is. If you click on Browse JumpStart, here, this is the landing page. So what is JumpStart? How do we make your life easier to get it quickly to start with SageMaker? JumpStart provides a collection of pre-trained open source models from all the model hubs, including TensorFlow Hub, PyTorch Hub, and Hugging Face, MXNet Hub. We also have pre-prepared end-to-end solutions for you to get started to solve business use cases. So we, at the same time, also handed to you all the example notebooks for you to learn how to get the code. we further have blogs and video tutorials to help you learn how to use the SageMaker. Now, let me just talk about each of the type of components here on the JumpStart. Now, first, let's just look at what do we have for the models. When we launched, we brought over 150 models from TensorFlow Hub, PyTorch Hub, and now we have increased our selection to over 329. So we have the models that cover all different kind of machine learning tasks. We have models for vision. We have models for NLP. So for computer vision, we covered all different kind of tasks. So if you want to look at what the different problem types we cover, you see we have audio embedding, object detection, text classification, text summarization, image classification, object detection, many of all these different types of models. Now let's take, for example, image classification model, which is one of the very, very popular type of computer vision tasks that people do. So for example, here is a popular model, MobileNet from TensorFlow Hub. So for this model, we make it easy for you to see how this model works. Now there is a description at the bottom that shows you that for image classification model trained on the ImageNet data set, what you can do is you input images, and the output of the model gives you classifications. And in this case, it's from ImageNet 1K, so which means that it puts the image into 1,000 categories and give you an ordered list of how likely this image belongs to these different categories. So here it gives you Egyptian cat, and the second one is tabby, and then becomes a dumbbell. So in fact, the model also produces the likelihood for or the probabilities for this image belong to each of the category. And here, similarly, for image of a dog, it produces a Labrador Retriever. So how do you use this model? Because this is a pre-trained model. So we make it easy for you just to deploy this model by clicking a button. Here, you don't need to write any code. If you deploy, then it automatically tries to launch an endpoint. So this is going to prepare your model and start to deploy SageMaker endpoint. As you can see, I have a lot of endpoints deployed on the left. And after you deploy to an endpoint, what happens is you look at this, we show you example code in a Jupyter notebook on how you use this model. And this is a short piece of code that is easy for me to execute. And what you can see is we are putting the two images and feed them into an endpoint that we just deployed. And here, this model says, oh, this is a tabby. Initially, I thought the tabby is the wrong answer. But when I look up the dictionary, tabby refers to the type of cat with dark spots on the fur. So in fact, it's a more accurate answer than what I can get. I can only say this is a cat, that is a dog, right? So this shows you how to use this. And here it generates also the list of labels. So that's how you use this model. So in fact, what can happen is you can also further fine-tune this model with your additional data. So here we prepared a default data set, TF flowers data set, for you to try out how to create a training job. You can also click a button to find your S3 bucket and upload your own data for fine-tuning. And the data format for fine-tuning, we give an explanation at the bottom to say, here's how you should prepare your data. And then you can click a button here and create a training job. For enterprise customers, what we provide are additional security settings for IAM roles, for VPC settings, and encryption keys, such that this model can be used in enterprise environment. And furthermore, in the earlier talk, when people ask, can you use all these things, use models programmatically? And for this one, in SageMaker JumpStart, we do provide API support for using all these open source models by using SageMaker SDK. So here, what is happening is we provide a collection of code, and when you deploy a training job or inference endpoint, what is happening is we are running SageMaker SDK in script mode. So here we retrieve the Docker containers for running this model. We retrieve the model, the base model, as well as the training script and inference script. And then the rest would be all straightforward SageMaker SDK. So this is how you use all of these computer machine learning models. So let me just go back to see. Now, for the solutions, what we have is when we launch, we have solutions to cover all different industries. Now, as you can see here, it covers the financial industry, fraud detection, corporate credit rating predictions, financial payment classification. We also cover general themes such as demand forecasting, time series forecasting. We also cover in automotive industry, predictive maintenance for vehicle fleets, in retail industry, purchase modeling, for privacy, for sentiment classification. So we have 21 different solutions here, and we are adding more to have more and more selection. Now, how do all these solutions work? So now let's look at, for example, demand forecasting. Now, demand forecasting is easy time series forecasting. So for this solution, what we take input as multi-dimensional time series data in tabular format. And here we use a example data set, which is electricity consumption of 321 users over a period of over 2 years. Now, the task is to generate predictions for the next day based on the historical data. And how did we do it? We actually implemented 3 time series algorithms. One is LSTnet, and the other is SageMaker Profit, and is Facebook Profit, and the third is SageMaker DeepAR algorithm. And we run all these 3 algorithms with hyperparameter tuning, and we help you to see what the prediction looks like over time for these 321 dimensions. And so there is a really simple architecture for this solution. We just run everything on SageMaker. Now, what you can do is you can launch this solution by clicking a button. What's happening behind the scenes is launching a CloudFormation template. And in this, you can also customize your IAM roles for deploying this architecture. And after you launch it, now you can find the launched solution on the left. And here is the demand forecasting that we launch. Here we handed you an end-to-end notebook that you can look at how this works. Okay, just a second. So now this is the whole end-to-end notebook that we prepared for you. And this notebook includes the data preparation as well as visualization, and shows you how to train and optimize an LSTnet model using Gluon TS and with a hyperparameter optimization. And then stage 2 will be using Profit and then the DeepAR. So now we hand you all this code that is ready to run. In fact, if you change the input data from the example data set that we provide to your own data, then this solution will work for you as is with no other changes. And you can see that here we have data prep and we show data visualization, generates what's the input data and what's the expected output. And we hand you all the code to configure hyperparameter tuning and how you run the HPO and train an LSTnet model, and you look at what the output look like and how do you visualize the training results. All the way to the end, after we help you to train all 3 different models. Now we show you, let me just quickly forward to this. So then we show you how you compare all the results. So for example, you can look at the root mean square error, or you can look at the mean absolute percentage error, and you see that after HPO, LSTnet reach a level of accuracy of 0.51. And then profit, the error dropped to 0.146. And then with DPAR, the error dropped to 0.116. So you see that the model keeps on improving. And the inference time increases, and the training time is the longest for DPAR. Now, in machine learning, there is no algorithm that does the best for all the data set. So here on this data set, this is how the different algorithms perform. Now, when you change this to your own data set, then the results will vary, and this table helps you evaluate the performance of the different algorithms and select the best algorithm for your data. So we also provide a visualization such that you can see how different algorithms perform. So this is how the solution looks like. Let me look at this here. So the same thing holds for all of the solutions. Now let me take another example for the solutions, which is let me see, detect the malicious users and transactions. And this one takes in also tabular data. And then it runs different types of algorithm from both supervised learning using a random cut forest, as well as using XGBoost, and use various methods such as synthetic minority oversampling and hyperparameter optimization to account for the sparsity of the records being fraudulent. So because when you have a very few transactions labeled as fraudulent, then the training results sometimes get biased, and you need different techniques to account for such kind of biasness. And this is how the solution works. And same after you deploy, we hand you the whole end-to-end notebook for you to execute and to customize. So for SageMaker JumpStart, with all these, and also, we have tabular models, we have auto-gluon models, which are state-of-the-art, very popular in the field as well. You can also explore all the 44 example notebooks. You can actually search through all of these things. So for example, when you say click on this, you can click on problem type. For example, look at the object detection, and you can select all of them. And this brings you all the object detection models. And you can further select which framework, for example. You can select the TensorFlow models. Then this gives you an easy way to find out where, identify which models that are your favorite that you want to use. Now, over time, as you can see, some models are fine-tunable, some models are not yet, and we are adding all these. For example, if you come back in 3 or 4 weeks, then all of these object detection models for TensorFlow will be fine-tunable. And to use all of these, so for example, we recently made all the image classification models to be fine-tunable, and here allow you to specify hyperparameters such as learning rates, beta, and also you can configure early stopping. You can decide to train only the top layer, or you can also decide on whether to reinitialize the top layer or not. So this gives you a full list of all the SageMaker features that supports your training needs. So with that, let me save some time for questions. So I just give you an overview of all what SageMaker JumpStart is. I didn't use any PowerPoints, given this is a very visualized tool. And you can use all of these models through SageMaker APIs. And you can try out all these solutions by clicking buttons. So I hope this can help you accelerate your machine learning journey on SageMaker JumpStart, and saves you a lot of time. Okay.
Thanks so much, Lee. Yeah, thanks for the overview. So I love that we have a theme today of how can we make it easy for folks to get started with machine learning across different platforms. We have a question here. So can these pre-trained models be deployed on offline platforms, let's say a Raspberry Pi?
As of now, we on the UI, we do not provide this support to say where you deploy. So here we only deploy to SageMaker endpoints. But we are adding the feature such that we can integrate with other SageMaker features like Edge to deploy to Edge devices. So that is going to happen if we come back in 6 months.
All right, and also for folks to know, there is another service called SageMaker Neo that compiles your models to different target platforms. So you can actually, if you have your model, it's not part of the JumpStart here per se, but we do offer model compilation. So you can compile models and then also optimize for deployment, let's say, for Raspberry Pi. There is this open source project, I think it's Neo AI. But yeah, let us know what you're looking for. If you have specific use cases, we're always interested in knowing what you're missing maybe today or what you're working on, and let us know. And that feedback helps us to develop those integrations. There's another question. Can we optimize the code with Amazon Neuron?
As of today, we don't. But I'd like to hear all these requests from you so that I can add this to my roadmap and to better serve customers like you.
Right, and just for everyone's knowledge here, not everyone might be familiar. So AWS Neuron is an SDK we're offering that is optimizing machine learning inference to work on the AWS Inferentia chips, so the custom silicon that Amazon developed. So yeah, let us know your specific use case, what integrations you're looking for, what you're working on. We're super excited to hear about that, and if you share that feedback with us, that's helping the service teams like Lee for JumpStart to understand and prioritize maybe future integrations as well. All right, any other questions here? And I put in the link here as well to SageMaker JumpStart. So if you want to poke around there, there's a list of those pre-built solutions, and also a little bit more follow-up reading on the pre-trained model integrations. How to open JumpStart? Good question, Lee.
Yeah. Okay. So SageMaker JumpStart is inside of SageMaker Studio. So if you want the UI-driven experience, so you need to go into SageMaker Studio. Now, for us, I can show you, how I get in. So this is SageMaker console. this page, then you see control panel that has a studio. So you need to create a SageMaker Studio domain. And then here I added my 2 users. So here gives you a button, Open Studio. Once you click this, then it opens up the SageMaker Studio. So to use SageMaker JumpStart models, you can click on this and use all these things through the UI. We also give plenty of example notebooks that's on our documentation, connected to our documentation page to show you how to use all these models in SDK as well, just like I showed you here through an example notebook.
Perfect. Yeah, and I'll just put in another link here in the chat. That describes here how to use SageMaker Neo to deploy your models for edge devices. So there's a couple of links there that will take you.
Yeah, thank you. And I know I've been talking to the PMs for SageMaker Neo to lay out the collaboration such that we can get the JumpStart models to compile with Neo. So there's some backend work needed. That's why it takes some time. It's not there yet at the moment.
But yeah, great feedback from everyone here. So keep the ideas coming. Keep share the use cases you have if you're looking for something. We're always super excited to hear those. All right, let me see. I think that's it. Thanks so much, Lee, for your time today and giving us a peek view here into SageMaker JumpStart. And another big thank you to Mark. He has been answering more questions here in the chat as well during the talk. Thanks so much to both of you for joining us today. And everyone, make sure to check out our next month meetup. We're gonna have a couple of speakers there as well. One of them is the founder, Doris from Linea. She's talking about how to simplify data science workflows. And we'll also have a look into, I think, Data Wrangler, SageMaker Data Wrangler, and how to integrate into MLOps workflows. So thanks, everyone. Check out next month meetup, and you'll find the recording of today on youtube.datascienceonaws.com. Thanks, everyone, and have a great week.
Thank you.